Happy evening. Welcome to the lecture on transmission lines and RF systems. The objective of this lecture is to see what is a transmission line and the transition from circuit theory to transmission line theory. So let us start by concentrating on the term transmission line. What do we mean by a line? If someone asks us to draw a line, what do we usually draw? It is something that has a starting point, an ending point, something straight, something curved, etc. Right? And what about the term transmission? It is something where we transfer information once again from a point to another point. Now combining the two terminologies, a transmission line is something where we transfer information from one point, usually called as a source, to another point which is called as a load. Now coming to the next topic of our interest, the transition from circuits to transmission lines. Let us first see what a circuit is. Now just take a minute time, reflect upon and draw a circuit. Right, so what do we usually draw in a circuit? It is a source, a load and components such as R, L, C. And what connects all these together? It is a wire. Then if a wire has a starting point and an ending point and it transfers signals, can we call the wire to be a transmission line? Obviously yes, the wire is also a form of a transmission line, but the laws that we apply in normal circuits cannot be applied to transmission lines. That is why we start to see what is a transition from normal circuit theory to transmission line theory. There are three factors that differentiates a normal circuits from what a transmission line is. Factor number one, it is the length of the line. What is the length of a wire we usually use in our normal circuits? We use circuits on our breadboards and in our normal laboratories. But what about transmission lines? They extend almost up to hundreds of kilometers. Have you ever wondered what powers up our work, our home and all the devices in our country and all the countries? Yes, transmission lines are the reasons for all these. So having the length of the line in mind, the first factor that differentiates a normal circuit from a transmission line is the length of the circuit, meaning length of the wire used in a circuit. Factor number two, velocity of the signal. How do you power up a normal circuit? We give a signal from a device such as a function generator having a very low frequency. But what about the velocity of the signals traveling in a transmission line? When I'm going to cover such a large distance, going to power up so many devices, the velocity of the signal will obviously be very high. Factor number three, it is the time delay. What about the delay between a signal at the starting point and the ending point in a circuit? Having the size of the circuit once again in our mind, the delay is going to be too small when considering a very small circuit. But what about transmission lines? We cannot say where the line starts and where the line ends, which means delay is a very big factor when we design the characteristic of a transmission line. Thus, having these three factors such as length of the line, velocity of the signal and the time delay between the starting point and the ending point, we can say that the laws we apply to circuits cannot be applied to transmission lines. So to just have a small recap, what we saw in this lecture was what a transmission line is and the transition from circuit theory to transmission line theory. Have your mind screwed up? Just think upon what kind of analysis can then be applied to transmission line, which is going to be our next upcoming lecture.